Hello and welcome back. This is our second example for the dynamic programming approach. We will be solving the longest common subsequence. So, before we define the problem, let's start with the definition of a subsequence. So, a subsequence is a string S that is obtained by deleting 0 or more symbols from S. So, for example, if we have president, yung mga subsequences ng president na string are pred, P-R-E-D, S-D-N, and predent, so P-R-E-D-E-N-T. Okay. So, in other words, the letters of a subsequence of S appear in order in S, but they are not necessarily consecutive. If it's a requirement na consecutive, then it's a substring. But for subsequence, pwede kang mag-delete sa mga yan. Okay? And then, the problem of finding the longest common subsequence is given two strings, A and B, we wanted to get the subsequence that is common to both. So the naive way of solving the longest common subsequence is try to enumerate all subsequences of each string and then get the intersection. And then from the intersection, you get the one with the maximum length. So ayun yung naive algorithm for solving the longest common subsequence given two strings. Another way of solving it is by drawing lines. So, if we put the sequence 1 sa taas and then sequence 2 sa baba, draw a line whenever there's a common symbol. So, we have P to P, R to R, E to E, and so on. And then, the longest common subsequence ay yung mga set of lines that doesn't intersect. So, identify a set of line na pinakamarami that doesn't intersect. So, for example, the LCS here is PRIDEN. So, if we look at PRIDEN, hindi siya nag-i-intersect. Another example is algorithm and then alignment. One of its LCS, so pwede multiple subsequence with the same length. One lang yung ALGM. So, if we look at ALGM, ALGM. Another longest common subsequence is ALGT. Another common subsequence is ALIT or M. There is a dynamic programming approach for this. And again, for dynamic programming approach, necessary na meron yung certain property, the recurrence relation that relates the characteristic of the larger instance with respect to the smaller instance. So, in this case, suppose we have two input strings, A and B. The string is of length M, the string is of length N, and the symbols are represented using A sub 1 to M, tapos B sub 1 to B sub N. Okay, so the len of ij is the length of an LCS, longest common subsequence, between substring A and substring B of length I and j respectively. Okay, so now we are relating the length of the optimal solution for the longest common subsequence. And the way how we describe it is, of course, using recursion. So, of course, lagi tayong may base case. And the base case here is if I is equal to 0 or j is equal to 0, meaning parang nandun siya sa before pa mag-start kasi we have index 1, no? Pag walang empty yung string, then ang longest common subsequence is 0. Okay, medyo obvious naman to. And then, for the second and third lines sa recursive formula na to, ang main difference nila is that there is this condition. Okay, so if A sub I is equal to B sub j, so ibig sabihin if A sub I is equal to B sub j, then the length of the longest common subsequence is the length of the longest common subsequence nito, okay, A sub 1 to A sub I minus 1, B sub 1 to J minus 1, plus 1 kasi 1 is the count nung equal na A sub I and B sub J. So, that's the first condition. The second condition is yung otherwise. Otherwise, kapag hindi sila pareho, then the longest common subsequence is the maximum between two choices. And observe that for these two choices, yung isa ay shorter while the other one is longer substring. So, for the first option, we have a shorter B and we have a shorter A naman sa second option. So, that's for the case where A sub I is not equal to B sub j. And we're hoping that in the subsequent B sub j plus plus, we can pair up si A sub I and vice versa, we can pair up B sub j sa mga susunod pang A sub i's. Based from this recursive relation, we can actually create a table that computes from the base case to larger substrings, larger values of I and j. And that is by populating the content of a matrix. And this is the algorithm pseudocode for computing the LCS length. And later on, we will provide an algorithm for getting the actual subsequence based from this one. Okay, so to explain the table, we actually have an n by m table. And our first so, regardless kung sino si n by m dito, but you need to create a table na nandito si string A and nandito si string B. Okay? So, for string A, you need to specify the content of the symbol na nasa A sub 1, A sub 2, hanggang sa A sub n. And then, for B naman, you need to specify the content na nasa B sub 1, that's P, B sub 2, and so on. Okay? And you need to have zero index before the actual start of the string. So, you have 0, and then you have 0 column. Okay? So, necessary ito because of the base case. So, this is 0, and this is 0 because of this one. From the base case, which has 0 column and 0 rows, we can start by populating this part of the matrix. Requirement that that there is a content sa taas, sa side, and sa diagonal before you can identify the content of this part. So again, comparing P and P, you have a match. So the content will be this number plus 1 because it's a match. And then put an arrow. Okay, and then for the rest of the elements of the matrix, either we can go this way or this way. So try muna natin yung row-wise. So, if we compare P and R, since this is not a match, ang gagawin natin is to identify kung sino ang mas malaki. Yung nasa taas ba o yung nasa left. Since mas malaki yung nasa left, then we copy the content, so we have 1, and then put an arrow previous dun sa pinanggalingan ng 1. Okay. So, sa lahat ng mga comparison na mismatch yung symbol na to and symbol na to, we put the max between yung nasa taas and yung nasa left. So, in this case, 0 or 1, si 1 pa rin. You copy the content, you put 1 and put an arrow pointing to 1. Okay? Ganun din sa column. So, if we populate the content of this item, then we compare if P is equal to R. Since P is not equal to R, 0 or 1. So, mas malaki si 1, so you put the content 1 and put an arrow going up. And since wala ng P dito sa the rest, then lahat yan ay hindi na equal sa P. So, we compare ito ba or ito ba or ito, and so on. So, you put an arrow. So, you can populate the content by doing the row-wise comparison and column-wise comparison and so on until makarating ka sa item in MN. Okay? So, in this part of the matrix. Okay, so the total running time for this algorithm is O of M times N because you need to populate the content of this matrix. And then for the memory usage, you need to have a separate you need to have a two separate matrix to store the content of the numbers and the content of the arrows. Okay, so we have two matrices, so that's 2 times M times N, and that is in O of M times N. Okay, so ganun yung memory usage ng longest common subsequence that utilizes the dynamic programming approach. Okay, at the end of the computation, you can get the len MN, and that is the longest common subsequence for the whole sequence from A and whole sequence from B. But we don't know yet kung ano yung longest common subsequence. And we can do that by following the output LCS algorithm, which is a backtracking algorithm. Basically, ang gagawin natin dito is to follow the arrow from MN position up to makarating tayo dito sa 0, 0 position. And to illustrate the manner how we do it is by first highlighting the direction of the arrow from MN to 0, 0. So, let's try to follow the arrows. So, going up, tapos left, left, diagonal up, and so on. Okay. And note that from this highlighted parts of the matrix, may mga elements that has a match. And that is the longest common subsequence. We do it symbol per symbol. So, ang mangyayari dito is that since this is a match, we have to output P, we have to output R, and then, ano pa ba yung may diagonal? We have I, we have D, we have E, and we have N. Since wala nang diagonal dito, then we stop. So that's the longest common subsequence. And the output here is PRIDEN because ito lang yung mga may diagonal sa highlighted parts of the matrix. Okay, so again, bakit ba important yung longest common subsequence? It's important because sometimes we are using this algorithm to compare real sequences, sometimes coming from biological sequences, pwedeng genomes from two different organisms, pwedeng DNA sequences or RNA sequences. So, important yung commonality ng dalawang sequences na yun because sometimes they are related. Okay, so that's the longest common subsequence. Our next example is the 01 knapsack problem.